Lesson 32, Properties of Special Parallelograms. The objectives of the lesson are to prove and apply properties of rectangles, rhombuses, and squares, and to use these properties to solve problems. The vocabulary: a rectangle, which is a quadrilateral with 4 right angles. A rhombus, which is a quadrilateral with 4 congruent sides. And square, which is a quadrilateral with 4 right angles and 4 congruent sides. Let's look at properties of rectangles. We have 2 theorems, 641 and 642, that are about rectangles. If a quadrilateral is a rectangle, then it is a parallelogram. So since we have 4 congruent angles, it is a rectangle. A rectangle is a parallelogram. 642 says that if a parallelogram is a rectangle, then its diagonals are congruent. So AC is congruent to BD. Since a rectangle is a parallelogram, all the properties that we learned before about parallelograms apply to rectangles. Let's look at an example. A woodworker constructs a rectangular picture frame so that JK is 50 centimeters, JL is 86 centimeters. We want to find HM. So HM is this little piece here. First of all, if it's a rectangle, then the diagonals are congruent. So that means that KM is congruent to JL. The definition of congruent segments says that KM equals JL, which is 86. In a parallelogram, the diagonals bisect each other, so that means that HM is 1/2 of KM. Substitute and simplify, and we get that HM is 1/2 of 86, which is 43 centimeters. We have properties of rhombuses. 643, 644, and 645 are all about rhombuses. If a quadrilateral is a rhombus, then it's a parallelogram. And if a parallelogram is a rhombus, its diagonals are perpendicular. So that means that AC is perpendicular to BD. And if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles, so that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, angle 5 and 6 are congruent, and angle 7 and 8 are congruent. You can also look at these because you have parallel lines that 3 and 7 would be alternate interior angles, 4 and 8 are alternate interior angles and thus congruent, 1 and 5, and then 2 and 6. Like a rectangle, a rhombus is a parallelogram, so all of those properties of parallelograms apply to rhombuses just like they do to rectangles. So let's solve some problems. Example 2a, we have TVWX is a rhombus, and we want to find the length of TV. So this side. A rhombus is a quadrilateral with 4 equal sides. So all of the sides are equal to each other. WV is XT and XT are the same. So we can set those values equal to each other. 13b minus 9 equals 3b plus 4. Subtract 3b from both sides and add 9 to both sides. And we get that 10b equals 13. Dividing both sides by 10, we get that b equals 1.3. So to find TV, we use the definition of a rhombus. TV and XT are the same. Substitute 3b plus 4 for XT. So TV equals 3b plus 4. If we substitute in 1.3 for b and simplify, we get that TV is 7.9. Another example of finding angles, if TVWX is a rhombus, we want to find the measure of VTZ. So VTC would be this little piece right here. Rhombus, if it's a rhombus, the diagonals are perpendicular. So that means that the measure of VZT is 90 degrees. And we'll substitute in 14a plus 20 for VZT. So 14a plus 20 equals 90 degrees. If we subtract 20 from both sides and divide by 14, we get that a equals 5. A rhombus, each diagonal bisects opposite angles. So that means VTZ and ZTX are the same. If we substitute in 5a minus 5 for the measure of VTZ, we get this, and we substitute 5 for a, and we end up with 20 degrees. Rectangles, rhombuses, and squares are sometimes referred to as special parallelograms because they share a lot of the same properties. Let's look at another example, verifying properties of squares. Show the diagonals of square EFGH are congruent, perpendicular bisectors of each other. So we're looking for the diagonals, so EG and FH, and we want to show that they are perpendicular and they are congruent. So step 1, show that EG and FH are congruent. So EG, we use the distance formula and we get that it equals the square root of 50. FH, we use the distance formula for that and we get that it equals the square root of 50. So they are congruent. Since EG equals FH, then EG is congruent to FH. So the first part of what we're showing is shown. Step 2, we have to show that EG and FH are perpendicular. So if we look for the slopes, the slope of EG equals 1 over 7. The slope of FH equals negative 7. Since 1 over 7 times negative 7 equals negative 1, they are opposite reciprocals of each other, and that means that EG is perpendicular to FH. Step 3, show that EG and FH are bisecting each other. The midpoint of EG is the point negative 1/2, negative 1/2, and the midpoint of FH is negative 1/2, negative 1/2. So they do bisect each other because they have the same midpoint. The diagonals are congruent perpendicular bisectors of each other. Let's look at example 4, properties in proofs. Given that ABCD is a rhombus, E is the midpoint of AB, and F is the midpoint of CD, we want to prove that AEFD is a parallelogram. So we start with what we're given. ABCD is a rhombus, E is the midpoint of AB, F is the midpoint of CD. ABCD is a parallelogram because rhombuses are parallelograms. AE is parallel to FD by definition of a parallelogram. That means that segment AB is congruent to segment CD because if a quadrilateral is a parallelogram, the opposite sides are congruent. AB then is equal to CD, definition of congruence. AE equals half of AB, and FD is half of CD by definition of a midpoint. FD equals half of AB by substitution. AE equals FD by the transitive property of equality. And segment AE is congruent to segment FD, definition of congruence. So AEFD is a parallelograms because a quadrilateral with one pair of opposite sides, congruent and parallel, is a parallelogram. Now you try. You're finding lengths and angle measures, and then you're going to graph these, and using distance, slope, and all you know about bisectors, you're going to show that these are true.